Alright, so this is properties of logarithms. This will help us expand, condense, and it's useful when we start solving logs, which we'll do, I think, next week sometime. So the first one is if I have log of a times b, I could rewrite this so I could expand it as log a plus log b. So you're separating it into now two different log functions with a plus sign. So multiplication turns into addition. So it's kind of similar to our exponent rules. When we're multiplying two things, you add their exponents. Same thing with logs. When I am dividing, this could be rewritten as log a minus log b. So again, our division rule was to subtract. So same thing with our properties of logs. If I have log of a to some b power, that really means I'm taking that b power and multiplying it by log a. So you're taking that b and moving it to the front, basically. So what we're doing today is we're going to condense and expand. And I'm pretty sure that your homework is mostly focusing on expanding today. So if I look at examples 1 through 5, we're all condensing them. We're writing them as a single log. That's what your homework is. Sorry, I was looking. Sorry to pause. All right, so example 1 through 5 is what your most of your homework is going to be. So I have log base 2, 10, plus log base 2, 3, minus log base 2, 5. So I'm going to condense this to be a single logarithm. So my final answer should only have one log. Okay. In order for this to work, they all have to have the same base. So here they all have same base 2. Now I'm going to rewrite this as log base 2. So I will only have one of those. And then I'm going to look at the operations. So the plus, if we look up above, it means multiply. So I'm going to have the 10 times the 3. And then the minus means I'm going to divide. So all of that divided by 5. Now, since these are all actual numbers, I can multiply them out and solve. If they were variables, then I would just leave them the way they are. So this becomes log base 2, 10 times 3 is 30, divided by 5 is 6. So this right here is my final answer. All right. Example 2, I have log base 3 plus 2 log x. So if I look, this piece right here looks like the last property. So that means that 2 was an exponent on the x. So I need to make that there. Okay, then I'm going to look at the operation here. So I have a plus. So the plus meant up here to multiply when I condense it. So I'm going to have log 3 times, and since I moved that 2 to be an exponent, x squared. So you could just rewrite it as log 3x squared. And since the base is not written, remember that it is implied to be base 10. Alright, on this one, I am going to look at the numbers out front. So the numbers out front tell me that this is an exponent on this entire thing. And then log x is fine. Minus tells me I'm going to divide. And then this 2 is an exponent just on the y. So I'm going to have my single log, the x from the first part, the minus tells me to divide, then I'm going to have y squared, and all of that is raised to the 3rd power. Okay, if you wanted to, you could have distributed the 3 to everything and gotten 3 log x minus 6 log y. And I can't write, sorry. Then you would still move both of those exponents. So you would have log x cubed divided by y to the 6th. Those are the exact same thing, because if I have a power to a power, you multiply the exponents. So 1 times 3 is 3, 2 times 3 is 6. So those are equivalent. So whichever one you think is easier to you. All right. On this next one, example 4, I have 1/2 log base 3x minus log base 3x minus 4. So what I'm going to do here is move the numbers out front to be the exponents, and that's the only one I have to worry about. So I'm going to have a single log base 3. My numerator will be x to the 1/2. The minus tells me I'm going to divide. And I'm going to divide by this entire thing here, so x minus 4. Now, you cannot leave it like this. The 1/2 power is the same as square root of x. So anytime you have a fraction exponent, you need to change it back to radical form. So I'm going to have log base 3 square root of x divided by x minus 4. And that is my final answer. Alright, on example 5, there are no numbers in front of the log, so that means there's no exponents that I need to take care of. So now I'm just going to write it as a single log. So I'm going to have a log, it's base 10 because there's nothing written, x squared minus 9. It's subtracting, so again it's division, x plus 3. Now here's the tricky part. I need to see, can I reduce it anymore? So all of the other ones prior to this were not reducible. This one you're going to have to go back to your factoring. So I can factor the numerator, x squared minus 9, that's our difference of perfect squares. I can factor that to be log of x plus 3 and x minus 3. Because positive 3 and negative 3 will give me negative 9, but positive 3 and negative 3 will give me 0 because that b term is missing. Divided by x plus 3. And now I can look and see they have x plus 3's in common, so those cancel one another. And I'm left with log x minus 3 as my final answer. So be careful, make sure that if it's factorable that you do that. Let's see. Alright, I'm going to go ahead and stop here for today because this is all that your homework is on, is the condensing to a single logarithm. So I think it should be good. The assignment is A6, page 465, 19 through 30. Alright, good luck.